Assalamu alaikum. My name is Saman Fatima. I am a student of PhD semester 1 in physiology from University of Veterinary and Animal Sciences, Lahore. Today, I am an online presenter in the IBBC 2024, and today my topic of presentation is effect of iron oxide nanoparticle supplementation on serum proteins, redox status, and histology of spleen in broilers. Here's an overview of an upcoming slides. Start with the introduction. As we know that poultry has various social and economic importance. So, as they have a part, as the part plays an important in the socio-economic economic importance, the most common that we were seeing in the poultry is an oxidative stress. Oxidative stress is an outcome of an imbalance between the reactive oxygen species and antioxidants. Iron is an essential trace mineral for various physiological health status. Iron oxide nanoparticles have a unique property of superparamagnetism. Serum proteins serve as a key component for pathological and biochemical test analysis. My study lies on the effect of iron oxide nanoparticle supplementation on lymphoid organs. So spleen, my main focus in my study, in my research is to to identify the effect of iron oxide nanoparticles on the spleen. So spleen is the largest secondary lymphoid organ. There are the various articles that shows the effect of iron oxide nanoparticles on different parameters of the poultry, like biochemistry, blood biochemistry, egg quality, laying performance, and antioxidant capacity or immunity. There are other articles that also shows the effect of iron oxide nanoparticles and their effect of different types of nanoparticles on the poultry. So my hypothesis is iron oxide nanoparticle supplementation improves the functioning of the spleen in broilers by enhancing the health markers and histological features of spleen in broilers. The current study was aimed to evaluate the effects of iron oxide nanoparticles on the relative weight of spleen, serum redox status. That includes catalase and NDA, serum proteins, which include total serum proteins, albumin, globulin, and albumin-globin ratio. For the materials and methods, we mainly primarily focus on the synthesis of the iron oxide nanoparticles. The brief procedure is first step, we take iron oxide and we prepare iron oxide nanoparticles in an aqueous medium by an addition of 25 ml FeCl3 to 25 ml of FeSO4 solution and allow it to stay for 30 minutes under a nitrogen atmosphere at 45 degrees Celsius to remove any dissolved oxygen. In second step, sodium hydroxide was added to the above mixture and stirred constantly on a hot plate magnetic stirrer for a further 40 minutes until a brown precipitates were formed. In third step, the precipitates were centrifuged for 8 minutes at 6,000 RPM and then washed with the deionized water. The washing water repeated for 4 times to purify nanoparticles and directly dried in an oven at 60 degrees Celsius for 24 hours. After the synthesis of iron oxide nanoparticles, we primarily focus on the characterization of the iron oxide nanoparticles. We check the characterization of the iron oxide nanoparticles by the two means. Number one is an SEM method and number two is XRD method. First of all, we talk about the SEM method known as scanning electron microscope. The obtained SEM image from the iron oxide nanoparticles shows crystalline nanoparticles, and SEM images of iron oxide nanoparticles show particles with an average diameter of 50 to 100 nanometer, which is a good agreement with the previous report. Second one is an XRD, known as X-ray diffraction, to identify the crystalline phase and chemical composition information of the prepared samples. The diffractograms were recorded at room temperature with Cu as the tube anode. The current was 40 milliampere and the voltage was 40 kilowatts. The main, for any research, the main component of is the experimental design. In my research, the experimental design I follow is I take 300 broiler chicks of 1 day old and we divide into 6 groups. Group A considered each group contains 50 birds per group. So in group A, we have no supplementation, simply the basal feed. In group B, we are supplemented with a bulk form of iron in a basal diet at 80 milligram per kg feed. And in group C, supplemented with iron oxide nanoparticles in basal diet at 20 milligram per kg feed. In group D, supplemented with iron oxide nanoparticles in basal diet at 40 milligram per kg feed. And in group E, supplemented with iron oxide nanoparticles in basal diet at rate 60 milligram per kg feed. And in group F, we are supplemented with iron oxide nanoparticles in basal diet at 80 milligram per kg feed. Total duration of my trial is 35 days, and birds were kept at 35 to plus minus 0.5 degrees Celsius and 0.5 plus minus 5 degree relative humidity. At the end of the trial, 2 birds from each replicate was slaughtered to collect the samples. All the birds were vaccinated for Newcastle disease and infectious bronchitis disease. So the parameter we studied is the relative weight of the spleen in grams. Second parameter is the serum redox status. Third is the serum protein, and fourth is the histology of spleen. In histology of spleen, we find out the length, width, area, and the number of the lymphatic follicles. For statistical analysis, we use SPSS-20YN, and data were analyzed by one-way ANOVA followed by a Duncan post-hoc test using a p-value 0.05. After the whole experiment, the results were shown as first, the result we study is the effects of iron oxide nanoparticle supplementation on the relative weight of spleen in broilers. Data of the experiment was presented in the form of mean value plus minus standard error. As you can see in the group, as I told you earlier, the group A is control, a group that contains no supplementation. Group B contains bulk form of iron. Group C contains a basal diet with 20 milligram per kg iron oxide nanoparticle supplementation, and group D 40 milligram of per kg iron oxide nanoparticles with a basal diet, and in group E 60, and in group F 80 milligram per kg feed. As you can see in the graph, the maximum response was shown in the group E, that is supplemented with 60 milligram per kg of iron oxide nanoparticles. Right? Next parameter is the effect of iron oxide nanoparticles on the serum malondialdehyde. So in this graph, we shown a maximum response in the group C that is supplemented with only 20 milligram of per kg supplementation. So there is not maximum response, but there is a corresponding there is not a maximum response, but they show the slightest increase in the group C. Third is the effects of iron oxide nanoparticle supplementation on serum catalase in broilers. And in this, the data was again represented in the form of mean value plus minus standard error, and the maximum response was shown in the group E, that was supplemented with 60 milligram per kg. Fourth is the effects of iron oxide nanoparticles on serum proteins. As we know that the serum proteins except the beta globulin that is synthesized in the liver. So in this group E shows a maximum response that was supplemented with 60 milligram per kg of the iron oxide nanoparticles. And in the serum albumins, the maximum response was shown in the group D. In serum globulins, the maximum response was shown in the group E, that was supplemented with 60 milligram per kg of iron oxide nanoparticles with basal diet. As in the serum albumin globulin ratio, the maximum response was shown in the group C, that was supplemented with only 20 milligram per kg of iron oxide nanoparticles. The last parameter we studied is the effect of, we want to determine the effect of iron oxide nanoparticles on the spleen. As I told you, spleen is second largest lymphoid organ present in the body. So for the morphometric parameters, we use Capture 2.2.1 software to take photographs of the slides of the spleen at the 4x Olympus. So first picture shows the length of the lymphatic follicle. Second is the width. Third is the area, and last is the number of the lymphatic follicles. As in the show the length of the lymphatic follicles, the maximum response in the group F, that was supplemented with 80 milligram per kg of iron oxide nanoparticles. In the width of the lymphatic follicles, the maximum response was shown in the group D, that was supplemented with 40 milligram per kg of the iron oxide nanoparticles. And in the area of the lymphatic follicles, the maximum response was shown in the group D, that was supplemented with 40 milligram per kg of iron oxide nanoparticles. And lastly, the number of the lymphatic follicles, the effects of the number of the lymphatic follicles on the supplementation of iron oxide nanoparticles. So there is a interesting response that was shown. As you can see in the graph, as we increase the iron oxide nanoparticle supplementation, there is a decrease in the number of the lymphatic follicles. So it means that you don't as we increase the supplementation, there is a decrease in the number of lymphatic follicles. So as in conclusion, we said iron oxide nanoparticle supplementation had improved the serum albumin globulin ratio and the width of the lymphatic follicles of the spleen. Mainly we said there is a maximum response, and there is a maximum response was shown in the lymphatic organ, which my choice of study is the spleen. So there shows a maximum maximum improvement in the spleen and the serum albumin to globulin ratio. So the lymphatic follicles count showed a decreased trend with an increase of the iron oxide nanoparticle supplementation. So thank you. It was all from my side. I hope you like it. Thank you. Allah Hafiz.